All right, hey, today what we're going to talk about is classifying, adding, subtracting, and multiplying polynomials. I know it says section 7, but this is actually what we called unit 4 for algebra 2. First off, let's take a look at a little bit of vocab here. We've got monomial, which is an expression, a number, or variable, or even a mixture of one or more variables. You take a look at all those examples that you have. Notice how they're all monomial is essentially saying one term. Okay, mono means one. A constant then is a monomial with no variables at all. So the difference between those is literally just an x or a y. A coefficient is a numerical number in a monomial or numerical factor. Okay, if you take a look at this here, if you have x, there's an imaginary number out front, that's coefficient 1. Negative 2 there, negative 2t, the coefficient is negative 2. And then we've got this fraction here. We've got a negative on the outside of the numerator, and we've got a denominator, so it's negative 1/3. You've probably heard this vocabulary before, but I am going to remind you of what a coefficient is multiple times throughout this, so just kind of be aware that it's the number out front. Next up, we've got vocab term, which is a polynomial. I'm sure that you've all heard of those before. A polynomial just means that we have multiple nomials or multiple terms added or subtracted together. The standard form of a polynomial is just taking those terms, looking at the degree and listing them from highest to lowest in terms of the degree. So for example, if I had something that said like x plus x squared minus 2, I would have to rewrite it as x squared plus x minus 2, okay, because it goes from greatest to least. Last but not least, we've got the degree of the polynomial. It's the largest degree of any term of the polynomials. Essentially what it is once you've ordered it in standard form, whatever that highest degree is out front, that is your degree of the polynomial. So for example, we've got x squared plus 3x. It has that degree of 2. And then x cubed minus 2x squared plus 1 has a degree of 3. Sorry. So now's the time, if you have a phone or something and you want to take a picture of this, it's a little chart to kind of help you along. Note that when we are looking at degrees, when we have 4 or more degrees, we just say blank degree. And then whatever number of terms we're actually going to have. So with degrees, if we have 0 degrees, that's what we call constant. If we have 1 degree, that's what we call linear. Okay. 2 degrees, that's what we call quadratic. 3 is cubic. And then 4 or more, we just say like 4th degree or 5th degree or so forth. We do the same thing with the number of terms. If we have 4 or more, we say polynomial of however many terms that is, blank terms. So like if I had 5, then it'd be a polynomial of 5 terms, 4 is a polynomial of 4 terms, and so forth. If you take a look there, these are the big ones though that we actually have names for. Just 1 term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and if you notice, each of those is separated by a plus or minus in order to determine the terms. So again, right now, if you want to take a screenshot or if you just want to kind of copy a couple things down, you can. If you need more time, just hit the raise your hand button. Otherwise, I'm going to move on. Every example that we do, for the most part, we are going to name and classify by degree and term. So take a look at example 1 here. Write each polynomial in standard form and classify it by degree and number of terms. So with this first example, I need to look for my highest exponent and then go in descending order. So negative 9x to the 4th plus 6x squared plus 7. And then you note this is a degree of 4, so this is a 4th degree. And then we have 1, 2, 3. So that would be a fourth degree trinomial. Example number 2, 8 plus 7v minus 11v. You always want to make sure to try and combine these terms if you can. So combine your like terms before you go ahead and start naming things. So 8 minus 4v, so I'm going to rewrite that as negative 4v plus 8, which then is a linear binomial. Why is this linear? Well, compared to a constant, if you remember, constants have no variables to them. And a linear would mean that my variable would have a degree of 1, which it does there. It's an imaginary degree. Questions so far? Okay, part 2 of the notes, we're just going to review adding and subtracting polynomials. I'm just going to take you through a couple quick practice problems that you've probably seen before or done before in math, especially whenever you were in geometry. Combining like terms, if you take a look, one of the first things that you want to do when you combine like terms is make sure that you distribute anything that might need distributed. So in this case, 4t squared minus 24 plus 6t squared plus 22. Next, when you combine your like terms, you want to only combine terms with the same variable and degree. So for instance, 4t squared and 6t squared become 10t squared. Notice I do not, and I'm going to repeat this again, I do not add the degree. Okay, you keep them the same. That means it doesn't become 10t to the fourth, it becomes 10t squared, then minus 2. Anybody want to try and name this? Okay, this is what we call a quadratic. Binomial. Quadratic because the lead degree, the highest degree is 2. Binomial because we have 2 terms. Right. This is probably one of the easier ones that gets missed the most by students, just letting you know. It's because most of the time a lot of students forget to distribute the negative. So even though we're going to drop the parentheses for the first part, we're also going to distribute the negative, essentially distributing a negative 1 throughout our entire back half. From there, combining like terms, 4x squared and a negative 6x squared become negative 2x squared. 5x and essentially 1x become 4x. And then 1 and negative 8 become negative 7. Which again is a quadratic because the lead degree is 2. And then we have 1, 2, 3 terms for trinomial. So you may wonder, why is it a quadratic again? It's because the lead degree is 2. If you take a look at both of those, I spelled binomial wrong. You guys are used to my spelling by now. The only difference is the number of terms. Any questions, or does anybody need more time at all? Here's our next example. Okay, in this case, we're going to take the whole negative 4 and distribute it to the back half. 30d3 minus 29d squared minus 3d. Distribute, so negative 8d cubed minus 4d squared. And again, combining like terms here, this is going to give us 22d cubed. This is going to be negative 33d squared, and then we'll just have minus 3d. Does anybody like to guess as to how to name this? Cubic trinomial, very good, yes. Cubic because the lead degree is 3, and trinomial because it has 3 terms. So part 1 of the notes, we talked about some vocabulary on how to classify. Part 2, we talked about adding and subtracting and making sure we distribute through. Just a reminder, review of distribution, you want to make sure you know this case to be 3x plus 6. Part 3 is multiplying, okay, and I'm going to show you how to multiply them just using distribution and then also FOIL method and then what I like to call mass distribution. So if you simplify this, we've got 3xy squared times 4x to the fourth y minus 2xy squared plus 5y cubed. One thing that you want to note is when multiplying, add exponents of like terms. We've kind of went over this before, but it's something sometimes it just doesn't stick. For instance, on this first one, when I distribute, 3 times 4 is 12. And then I have an x of 1 and an x of 4, so I now have x of 5. Okay, we're adding the exponents. Y of 2 and y of 1 become y3. Distribute again, I have negative 6. I have x and x, which then become x squared, because anytime that you have just a variable, there's always that unmentioned 1 at the top of it. And then y2 and y2, which become y4, adding those, not multiplying. Last 3 and 5 give us 15. And then I don't have any other x's, so I'm just going to leave the one that I started with. And then y2 and y3 become y to the 5th. All right, this is something that I kind of want to go over real quick. You touch more base on it in Algebra 3, but how to name degree with multiple variables. So if you look at some of the other examples that we've had, they've always just been one different type of variable. When you have multiple variables, you actually add them within the term. So like 5 and 3 is 8, 2 and 4 is 6, 1 and 5 is 6. So when you're doing this, okay, you want to pick the highest degree. So in this case, it would be an 8th degree trinomial. And again, you touch more base on that in the next math class, but I just kind of wanted to give you a heads up on it. When you have multiple variables, in one term, you add the exponents together, and then once you do, you find out which one has the highest degree. Okay. I'll even put that add variables. All right, I've only got 2 more examples for you here. This one is a review of FOIL. Hopefully you're all familiar with FOIL from last year and then some from this year. FOIL is literally just double distribution. I like to take my finger and cover up the 4 and then distribute. And then I like to cover up the 3x with my finger and then distribute. But if you remember FOIL, FOIL stands for first, outside, inside, last. So first, 3x times 2x. Outside, 3x times 5. Inside, 4 times 2x. And last, 4 times 5. Which then would simplify 3 and 2 multiplied, give me 6. And then x and x is x to the second. So 6x squared plus 15x plus 8x plus 20. Find the middle terms, and I get 6x squared plus 23x plus 20. Now, some of you might be able to skip that first step where you write everything out. You might just go straight to the middle stuff, which is fine. But some of you might need that extra one, which is totally okay. Does anyone want to classify this for me at all? Try classifying. Okay. This is a quadratic trinomial. I'll give you a second if you need to copy anything or have any questions. Now, here's the deal. I have a FOIL video, I'm sure, in your video resource tab. If for some reason you get stuck with FOIL, boys and girls, I really hate to say this, but it's true. If you Google FOIL method, there are so many videos and so many different example problems that you could do. There's teachers out there that are way better than myself showing different FOIL problems. So take a look at those if you're interested. Some of you that might be math nerds like myself. And you'll also find some videos like example number 8 that might help you along as well. This is a review of multiplying trinomials. So I'm going to show you first how to multiply the binomials, and then we'll talk about that big trinomial. For those of you that don't exactly know what I'm talking about we have to multiply 3x squared minus 2x plus 3 times x plus 3 times x plus 3. Remember, this little exponent or degree means that there's 2 of them. Now, you could do x plus 3 and distribute it throughout the first trinomial if you wanted to. I'm actually going to do this a little backwards. I think it's easier. I'm going to multiply the binomials first using the FOIL method. So 3x squared minus 2x plus 3. And then when I do that, I actually end up with x squared plus 6x plus 9. Off to the side here, just showing you how this is done. It would be x squared plus 3x plus 3x plus 9, which would end up then giving you the x squared plus 6x plus 9. I'm going to color code each of these steps for you. I'll start with green. I'm going to take this first term and I'm going to distribute to each of the back 3. So here I get 3x to the 4th, because remember, when I'm multiplying, 3 times 1 is 3, but then I add the exponents. I only add exponents when I multiply. Okay? Do not do that whenever you're adding subtracting. Only when I multiply. So then 3 times 6 is 18. And then I have x to the 3rd, because I have x squared and then 1x. And then 3x squared plus 9 gives me 27 x squared. Next step I'm going to do in red, like I said, to help color code, I'm going to multiply by negative 2x to x squared, 6x, and 9. So negative 2x times x squared is negative 2x cubed. Negative 2x times 6x is negative 12x squared. And negative 2x plus 9 is negative 18x. And I'm going to be very real with you guys. When I first started doing this way back when I was your age, I actually just used my finger and covered everything up. I know you can't see it through the screen, but I would with my fingers, my one, because I'm right-handed, with my left hand, I would cover up negative 2x plus 3, and then I would distribute the 3x squared. And then I'd use 2 fingers and cover up and so forth. You could totally do that. That's okay to do. Just because you're in 10th grade doesn't mean that you can't use a couple tricks. Okay, and the last I'm going to distribute, I'm going to distribute the 3 here. So 3x squared, and then 3 times 6 gives me 18 with the x, and then 3 and 9, which is 27. Putting it all together, I only combine terms that have the same degree now that I'm adding. So 3x to the 4th is by itself. Then after that, I have 18x cubed, negative 2x cubed, and I think that is all I have. So I'm going to have 16x cubed. Then I've got 27x squared, negative 12x squared, and 3x squared. So 27 minus 12 is 15, plus 3 is 18. 18x squared. 18x, negative 18x, and positive 18x cancel each other out, and left is 27. This would be a 4th degree polynomial of 4 times. Any questions at all?